So I'm going to go ahead and start. If you're joining us for the first time, you don't have to follow up because I mean there are like a number of other things we have discussed before now. So but you don't have to get it just yet, right? If you're joining for the first time, just pay attention, grab what you can, and then afterwards you will be able to go back and watch the other videos. The So some of the things we have talked about in the past have basically been some of the basic things in Python. We've had like 2 sessions on Python. The first one was, really introductory stuff, how to install it, how to open it, how to interact with it, and things like that. And we kind of got deeper in our last class when we started talking about variables and uh, constants and reserved words. So if you are coming from that class, if you've been in that class, we are going to be continuing from where we stopped. And even if you weren't in that class, afterwards, you can go back and review those other classes that we've had. All right. So I'm going to share my screen a little bit just to make sure that I'm carrying everyone along. I'll start with sharing my entire screen. Let me know when you can see it. Okay, so if you can see my screen, please let me know. All right, thanks, Victor. Okay, so for the meantime, just know that we've had a few sessions before now, and some of those sessions we set up our computer in one of those sessions where we installed Python, we installed VS Code, a few other things, and we had another session where we learned how to open up Python and interact with it. So I'm going to show you just a little bit of a way of just carrying you along. What I'm doing right now is just opening up the terminal on my laptop and I can go ahead and interact with Python that way. You know, so this is the interactive mode, but we don't use Python this way because there is a better way to use it. So I'm going to terminate this, and we have also set up VS Code. So I'm going to open up VS Code, which is basically like a text editor. So we use Python this way by writing scripts into the Python file, and then we're able to run our code on the terminal this way. So this is a preferred method. So the other time we worked on these things where we talked about variables and we talked about assignments. We talked about the values of the variables. So today we are kind of gonna go more deeper and discuss something called expressions. So I'm gonna stop sharing my entire screen and I'm gonna share just my VS Code so we can continue from there. Can you still see my screen? All right, please let me know. Can you still see my screen? Can you confirm what you're seeing on the screen? Are you seeing a code? Are you seeing some code, or are you seeing a picture? A picture or a code? Come on, you guys, talk.
Picture. The picture. PNG.
All right, cool. Okay, I wanted to make sure that it's sharing correctly. Righty, thank you, Victor. So like I said, so we have kind of done very basic things like this, whereby x is our variable and 5 is our value, and then in Python, this is a valid Python code that assigns 5 to the variable x. And today, we kind of want to focus on what happens on this right-hand side a little bit, because on the left-hand side, we usually have our variables, so we can name this variable whatever we like. It could be days of the week, and 7. All right, so this is a classic example of a simple Python code that tells Python that, okay, we have 7 days in a week. But of course, Python doesn't really understand this in English terms. He just knows that, okay, we have a value, a number 7, that is important to us, and we want Python to remember it. So we tell Python to remember it with this variable, days of the week. So Python knows, okay, I'm going to make a space in the computer, find a storage location in the computer, and I'm going to name that location days of the week, and I'm going to save 7 in there. It's kind of simple like that. Python code, programming in Python means, going further from here and doing more complex stuff, like if we wanted to do something like 7 plus 2, right? So we are going to focus on this right-hand side and see all the other things we're going to do here. And we'll learn a little bit more about how Python works and all the things that Python can help us do by going into these things in details, right? So the first thing that we're going to look at is something called operators in Python. So we have kind of already seen a number of them when we did plus, minus, and multiplications. So those are the operators in Python. Who is not on mute? It's alrighty. Okay, we're getting more people in, and that's awesome. But you guys should try and be coming on time so that you can follow from the beginning. So like you have seen already. So we have a number of other operators that we kind of want to look at. So I'm gonna show you. I'm gonna stop sharing my screen. I'm gonna share a whiteboard and kind of internship day 4. Yes, that's the one. Yeah, kind of look at the operators. These are basically most of the operators we have in Python, and there is a little bit of background stories to them, but the very basic one, um, the addition, the subtraction, the multiplication. So you will notice that we are using asterisks for multiplication, right? So the thing is, when they built Python, and Python is kind of like a new thing, but like before we even have Python, we've had like typewriters, and those were kind of like from where we got the keyboards, and eventually all those things are built into the computer. So, but back in the days, um, they did not really have a way to represent all the operators on the keyboard. And today, if you look at your computer keyboard, you will see that, like for instance, the division sign, it's not there. So we use slash for division, and then the multiplication sign, which is basically X, we use asterisk to represent it. So Python inherited these operators, by the virtue of the fact that these things, they are not on the keyboard. So we need to use something people can actually type, find on their keyboard. So that's why we use asterisk for multiplication, and for division we use slash, and then the third one is the power, raised to power sign, the exponentiation sign, right? And then the last one is the remainder, also called modulo operator. All right, so I think everyone is familiar with the addition. I mean, if you're not familiar with these ones, you probably don't belong to this class. So you're supposed to be familiar with addition, subtraction, multiplication, and division. And then for the exponentiation sign, this is usually what we use to do our raised to power. Give me a sec. Looks like there is a message in the group. Okay, so the the power operator helps us do things like raise to power, and then there is the remainder operator. Now this one is a little bit funny, and I'm going to show you how all of this work in a little bit, but the last one, yeah, is kind of a little bit funny, and I'll give you some example of how we use it and why we even need something like that in the first place. So okay, let's go back to our VS Code and kind of practicalize these things a little bit. Okay. So if you're writing a Python code, of course, and you need to add something, of course, you can always do 1 plus 2, right? And then when you run it, test.py, okay. And then when we print x, we're going to get 3. So basically, if you're not following, this is a valid Python code, right? And then Python, for you to read it, the way Python reads it, Python is going to start from here. Python is going to get this too. So Python starts from the right hand side to read your code. It doesn't start from here. It starts from here. He gets this too, and then he says, "Oh, okay, that's a number too. What do you want me to do with it?" You know, and then you said you give it an addition operator, and then Python is happy. It's like, "Oh, okay, now I have an idea. It looks like you want to add this. Where do you want to add it?" You give it another value 1. It says, "Okay." So Python gets this, no problem, and he meets this equal sign, and as you probably know already, the equal sign doesn't literally mean equals in Python. It's just a way for us to assign something to a variable. So it's an assignment. The equals in Python, when we actually need to do equals in Python, we use double equals. So this is the equal sign in Python. Okay, so Python gets these values, and he gets, oh, okay, you want to assign it to X. Then Python goes on our laptop, finds a storage space, he labels that place X, and then he saves this value there. And then when we run it, Python basically goes back to that location and finds whatever is in there, and then when saying Python prints it, then Python prints it. So please help me admit people who wants to join. If you see anybody trying to join in, just click on admit. Anybody who is already in can help us admit people who are trying to join. Thank you very much. All right. So this is your classic simple code in Python, right? So we are looking at the operators. We can do division. We can do subtraction. Okay, we can do addition, we can do subtraction. We can do multiplication. We can do division. And then the other one, we can do exponentiation, which is basically 1 raised to power 2 raised to power. And then the last one, which is the funny one, we can do the remainder. So a little bit of what is going on here, right? The modulo operator, the remainder operator, it means that when we divide something, we pick the remainder. We don't care about the whole answer. We just need the remainder, right? So, what is for instance, let me use a more practical example. Let's say we do. So this is basically 3 divided by 23 divided by 5. Normally 23 divided by 5 will give us 4.6. So when we use the modulo operator instead, we're only getting okay, that's a little bit problematic. Oh, okay, yeah, right. So now the modular operator gives us 4.6 when we do division. That is your normal mathematics, right? So, but when we use the modulo operator, we are saying if 5 go into 23, how many times can it go? 5 can go into this guy 4 times, obviously. Then it's gonna remain something. That thing that is remaining, that's what the modulo operator gives you. So it's kind of like when 5 go into 23, it goes into 4 times, which means 5 can go into 20 comfortably. So 5 going to 20 to give you 0. So that means 5 going to 23. Then it can go into 20, but then there is 3 remaining. So 5 going to 23 is going to be 4 remainder 3. So that remainder 3 is what this value gives you. And you're probably wondering, why do we need something like that? Well, it turns out that there are actually real life use cases for it, right? So one very popular one is we use it to find out if a number is odd or even, right? So that example is, we usually use it to loop around things and maybe make some the decision whether based on whether the number is even or odd, right? For instance, we know that anything divided by 2 is either 0. So is either going to give you, is either going to anything divided by 2, right? Is either going to work, when 2 go into any number, 2 is either going to be able to divide it if it's even number, or if it's an odd number, it will have some remainder, right? So if we are trying to decide if a number is odd or even, we can just divide it by 2. So if there is a remainder, we will know, okay, this number is an odd number. But if there is no remainder, we'll know, okay, this number is an even number. So finding out if a number is even or odd is one use case scenario where you can use modulo operator. For instance, if you go ahead and we run this code, we will get 1, which means this is an odd number because there's a remainder, but what if this number is 24? We'll get 0, which means it's an even number. So that's one classic use case. What's going on there for the modulo operator? Okay, now you know about the operators. The operators are one of the basic building blocks of Python, because a lot of what we do in Python is writing complex code and using all these operators to manipulate them, to add, to remove, to determine whether it's an even number or not. Just as a step for us to achieve our bigger goal, which is usually to complete a set of tasks, using Python. So the other thing that I want to talk about, just like in mathematics, there is something called order of operations, and it's kind of like the order in which Python does uses these operators, especially in scenarios where you have many of these operators in a single line of code, right? So, for instance, if we have something like this now, for instance, we have an addition operator here. We have exponentiation. So this is basically how Python reads this code. Is it takes, okay, there is 5, there is, he wants to multiply this, he wants to, this one is raised to power this one is dividing, this one is addition, so they are all lumped together like this. Which one is Python going to do first? Is it going to do the addition first? Is it going to do this, the exponentiation first? Is it going to do this first? So there is an order to it. And let me show you what that order looks like in a bit. So I'm going to stop sharing my VS Code and I'm going to show this whiteboard a little bit. Okay, so we call them the operator precedence rules. It's kind of like, what is the order in which Python does the maths in your code, right? So first of all, Python will process anything in parentheses or in bracket. So anything you put in a bracket, Python is going to do it first. Kind of like the way it works in math, I think, right? And then the next thing, Python will do exponentiation. And then the next thing, Python will do multiplication, then it will do division, and then it will do your modulus operator, your remainder, right? And then Python will do your addition and subtraction. And then Python goes from left to right, depending on if everything is everything, for instance, is in parentheses, then Python will start from the left of the mathematical expression to the right, which is kind of different from the way Python reads code normally, because Python reads your code from right to left. All right, so it just changes a little bit. These are written down rules because they help us write our code. They help us read code properly, right? So we're going to see this in action with the example we have. Remember, parentheses first, then exponentiation, then multiplication, then it does your addition, then it goes from left to the right, assuming they are all the same. Okay, so in that case, we can use some examples. Let's get back to our VS Code. We do have quite a number of things to cover today, so it might sound a little bit rushy. But let me know if you're feeling lost at any point. So we have our classic example here, right? So remember, the order is let me put them inside the let me kind of put them here, but I'm going to comment them out, and I will teach you more about what I just did in a little bit. But for now, just so you don't get confused, this is a comment, and I can add comments inside my code, and I'm going to tell you why. So in this case, I want you I want to make sure that I have the order of the order that Python used to read our solve our mathematics. So I'm putting them here. So first of all, parenthesis comes first. Do we have a parenthesis here? No. Then anything inside it will get evaluated, and then the exponentiation comes second. Do we have exponentiation here? So basically, Python is going to do this first. So it means that the way Python will read this code, for instance, is basically going to be, it's basically going to do this guy first. So 3 raised to the power 3 is 3 times 3 times 3. That's 27. So Python is going to solve this one first, right? And then Python is going to do multiplication. That means we have a multiplication here. That means Python will do this one first. They will do this one second. So 4 times 5, that will be 20, right? Yeah, that's right. So this is how Python solves it, and then the next thing on the line is division. Then Python is gonna, do this guy. Mm, no, that's not right. Division comes second, actually. Division comes before multiplication. This is not right information. Yeah, it does division first of all. So I'm going to undo this. I'm going to shift this one here. All right. Okay. So that was some error with the initial information. So they resolved this guy, Abi. So we have 27 here. So the next thing in line is the division. So it goes ahead and it does 4 divided by 27 divided by 4, and the answer based on what I have is 6.5. So it goes ahead and then it does multiplication. It does this guy multiplication, and then this 5 times this guy gives us this, and then it goes ahead and then it does this guy, which basically will give us 34.75, right? So this is how Python evaluates it, right? So x is equals to 34.5. But that is me trying to evaluate it like Python, right? So if I go ahead and I run it, if I go ahead and I run the code, it better give me 34 points, whatever. Yep. So that's what I wanted to show you. So that's the order. And it's kind of important because if you're learning programming, you're learning Python in 2025, these are the things you actually need to know, right? You might not need to come up with them anymore, because you probably need to just type in a prompt into like a Copilot or ChatGPT or whatever, and then you generate the code. So you want to focus on being able to understand the code, right? But I don't encourage you to memorize any of these things because the information is always available. Let's say you have a code and you come across something like this, right? You just need to know there is an order to the way Python, does it. So if you want to understand what is happening here, in order to understand this code, you can do a simple Google search of this information about maybe something like what is the order that Python takes the operators in Python. What is the order for the operators in Python? And you're going to get that information, then you'll be able to do it, right? So there is no need for you to cram this or memorize it. It's just for you to know that they exist. so that when you need it, when you try to we try and make sense of a Python code, a piece of Python code, you'll be able to do that, right? So that's the whole point. So the last thing is just like we see in number one, parenthesis always comes first. And this is one of the most important part, because sometimes you don't want Python to use his own order. Maybe you're trying to achieve something else, and you want to make sure that Python does this one first. Then all you need to do is to put them. All you need to do is to put them in parentheses. So if you do something like this, you are forcing Python to evaluate this guy first before anything else, right? So in this case, Python will do 1 plus 3 first. Then it will continue with the correct order that it does mathematics. All right, so that covers it with the operators. Do you guys have any questions so far? So far, so good. No questions. Alrighty. Okay. I'm going to go ahead and talk about types a little bit. So there is something we call types in Python, and it's kind of a way that Python classified information. The things that the values that you give it. How does Python make sense of it, right? We have kind of talked about this a little bit in the previous class, but I just want to touch it again. So basically, Python is smart enough to know that, when we give it, 1 plus 4, that's integers. It looks at the numbers and it says, oh, okay, those are integers. I know what to do. He's able to add them. But what if we give it hello plus world, for instance? Now Python doesn't go, oh, that is an addition operator right there. Let me go ahead and add it. No. Python is smart enough to know that, okay, this is a different type. This is not numbers, this is words. So when you give it hello plus word, Python would do what we call concatenation. So instead of adding it, it will kind of just merge them together so that he knows that you're trying to put these two words together. So Python does that. So that's kind of like the thing about types. And if you're curious about what a type is, what a type of a value is in Python, you can always find out using something called type operator or type function, right? So for instance, if we want to find out what type X is, we will do type X. And then when we run this code, okay, looks like we need to print it as well. The Python tells us that the class of this is float. Why? Because it's a floating number. Float is any number that has some decimal behind it, right? So what if X is 10? If we go ahead and we run this code, Python will tell us that X is an integer, right? So we use the type operator to find out what type a value is. This is very necessary if you're trying to debug your code. That's the very typical use case for this type, right? So what if this guy is hello? Python understands and tells us that X is a string, right? So that's how we use Python. That's how we use types in Python. Sometimes, you don't necessarily need to do anything like this, unless maybe you run into a problem and you're wondering, what a type a certain variable is or a certain value is. Maybe you're not familiar with the value because you're receiving it from your client or your customer or your user, and your user needs to maybe type it in or something like that. So you can use a type to find out. When you now find out that, okay, maybe it's a float or integer or is this, and maybe you can do something we call type conversion, which allows us to convert from one type to another. And that's also very typical um, use case, right? So for integers versus floats, it's basically whole numbers. Integers are whole numbers. Floats are whole numbers that has a decimal point, right? Once you put a decimal point, Python now sees it as a float. Um, there is a little fun fact. We don't used to use floats in when we are talking about money. So if you're doing anything that has with money, maybe you're building an e-commerce website, and you have to deal with the numbers and monetary values. We don't use floats, right? Okay. Let's let's just go over these things again. I think the most important things we have covered right now is the operators, and we also covered the order in which the operators are evaluated in Python. We also covered how to use the parentheses to change that order if you need to. We also talked about types, how Python deal with floats and integers and strings, and how to use type operator to figure out what's or type function to figure out what type a value is in Python. And the thing is, sometimes you're gonna make a mistake, like sometimes you might do something like this, whereby you did not put this hyphen, and then Python is gonna run into some issues. So you're gonna get error very fast, telling you that, oh, some Python did not understand you, because whereas you know you can understand this, Python can't, because when you're trying to give Python words as strings, you have to put them like this, or you can use single quotes as well. You can use double quotes. Anyone will work in Python. So whenever you get type error, maybe check whether you're using the types correctly. So that's a common problem, a common error that actually comes up. All right. I think we still have time, so I'm gonna go ahead and dive a little bit more into uh, these conversions. So we have talked about variables, we've talked about constants, we've talked about types and expressions, and these are the core pieces of any Python program. And the reason why we are learning about them is these are things we need to be familiar with, we need to know for us to actually write our first complete program in Python, which is kind of like our goal, right? So, but these things might look like very simple, small details, but they're actually really important. If you miss any one of them, it's kind of difficult for you to get the bigger things, because eventually we're gonna get more complex. So while you are at this level, you really want to just, kind of like sit back and go over them a few more times, right? So like you're not expected to just get them once, because you were in a class like this. It's something you kind of get used to, because so you need to kind of go back on your own and practice and review the lectures and make some research on your own, and kind of try out different things that will kind of reinforce that knowledge, that okay, you're now familiar with these basic things like variables and all of that stuff. So I encourage everyone to kind of make out time on your own outside the classes and really try to play with Python. That's how you reinforce the knowledge, kind of like the way kids learn stuff. They're just everywhere. Whatever they see, they touch it. They know how. That's how they learn how it feels. If it's very hot, then maybe it's fire. Then maybe we need to stay away from that one. So maybe if you type something wrong and you get an error, okay, that one we don't do that, right? So very, very important for you to practice. Very important. Okay. So let's talk about. So okay, there is a small thing in Python that I wanted to talk about. It's something called integer division. I think integer division is basically it's just division. Basically, it's basically division. But in terms of the actual use case, when we do something like this, when we do something like this, like 10 divided by 2, we're not trying to print the type, and we want to print x. We go ahead and we get 5.0 as a float, right? So this is very important. When Python does a division in Python 3, it gives you the answer in floats. But in Python 2, when Python does, I think maybe I can actually try it, because maybe I have Python 2 in here. Maybe. Okay, I don't. Okay. What if I use Python? I don't. Okay. So I don't have Python 2, but I would have shown you this in action. But the point I wanted to make is, if you have Python 2 installed on your laptop and you do something like this, you do something like this. Let me clear this terminal. And you run this code, you will get 5, not 5.0. What this means is that if you're on Python 2 points, if you're on Python 2, and then maybe you do something like this, you will not get 5.5, you will get 5. So that was kind of like a problem in Python 2. In Python 2, it was kind of like a big issue. So people needed to be very careful. Everybody just use floats. So instead of doing something like this, you do maybe something like this in order for you to get 5.5. So in Python 2, it just throws away the remainders. Whatever is here, it throws them away when you do division. So, but that have been corrected in Python 3. So when you do something like this in Python 3, it will give you 5.0 instead of 5. So Python 3 just kukuma, it converts everything to floats. It's a little small difference in Python 2 and Python 3, but that can cause a big problem if you're starting out as a programmer and you're not aware of this issue. Knowing that in Python 2, when you do division, it just rounds it up. It doesn't give you whatever the remainder is here. So, but it has been corrected in Python 3, and then we don't need to worry about it anymore. So if you're having some issues on your code, you just want to see whether you have Python 2 or Python 3, and whether that could be the cause, because of the slight difference in the behavior of the two Python versions, right? So that's one thing that I needed to point out before moving to the next thing. So there is a way for us to convert from one type to another, and it's kind of necessary. We have already talked about how Python knows, to differentiate types, knows that this is an integer, knows that this is a float, knows that maybe something like this is a string. But of course, this is commented out, so Python doesn't really see them. So there are times when you want to convert from one type to another, right? For instance, right now, when we run this code, we get a float. What if we want to get an integer, right? So you can convert this into an integer by using type conversion in Python. This is usually very necessary if you're dealing with inputs from user. If user needed to type in the number or type in something and you don't know, maybe they might type the wrong thing. We usually use type. We usually use conversions to do it. So a good example is we have an example here. So if I want to make sure that Python doesn't convert this to float, what I can do here is I can do so if I go ahead and I run this code, I'll get 5 instead of 5.0. Now this is a very little thing, but very, very important, right? There are very many use cases where you will do something like this. Now, what are we doing here? We have a 10 divided by 2, which is 5. And then normally Python will print 5.0, but we added another line that makes sure Python converts whatever the value of x is to an integer. So we use int. We have other types here. We can do floats, and we'll get a float. We can do, I think we can do string as well, and then we'll get a string. So, but in this case now, Python is printing this as a string. So that there are probably some use case for it. So, but in this case, we are just dealing with numbers. So there are not many use cases where you want to convert your number to strings. But there are many use cases where you want to convert your strings to numbers, right? And I will give you an example. Let's say you have let's say you have something like this. 1, 2, 3. Let me remove the conversion. If you print 1, 2, 3, Python is gonna fine and good. It's gonna print the integer for you, right? If this is a string, Python is gonna print yours. So the difference here now is the types, right? If if we check what type this is, if we check what type this is, Python will tell us that this is a string, right? And then if we check what type this is, then Python will tell us that this is an integer, right? So that's the, I mean, it's 23 is 123 is 123. So, but one is a string, one is an integer. This is very, very important because if you are receiving these inputs from a user, you will most likely receive them as a string. So you always want to convert them to integers. And I'll show you an example in a little bit. So we use inputs to receive something from user. So this is how we receive values from user. So instead of giving us, instead of saying X is this, if I put inputs and I run the code, Python is now going to ask me for the inputs. Then I can now type it. So I can type 123. And then what happened here is that here we want the user to type in a value. So Python received the value when I run this code, Python prompts me for the value. So Python received the value, and then Python assigned it to X. All right. And then Python went ahead and printed the type of X, which is a string. So usually user input is a string. But what if I want to receive input? And let's say I'm trying to do multiplication, right? I'm trying to do multiplication. So I'm asking the user to put the first number, and I'm asking the user to put the second number. And then I want to go ahead and I'll say C equals to X times Y. And I want to print C. So if I go ahead and I do this, Python will ask me for the first number and I put it 2. He asked me for the second number, Y, and I put it. Okay, let me just use 3. The Python runs into a problem. Why? But this is 2. This one is 2, right? I put in 2 here and then I put in 3 here. Then I ask it to multiply. So you need to know that the inputs always come in as a string. So there is a need for us to convert them to integers before we can use it to do multiplication, right? So if we comment this line out, and we want to find out the type. We want to find out the type of that Y is. And I put 2 here and I put 3 again. Tell me that Y is a string. So that's what I wanted you to know. So, but if we go ahead and we do something like this, X equals to int X, Y equals to int Y. what we are now doing is we are receiving an input from user. We are receiving an input from user, and we are converting those inputs to integers. We are converting it to integers. So Python knows how to does the conversion. You just need to tell it to do it, right? So once you tell Python to do it, it will do it. And now, if we run this code, we'll see that okay, it's asking me for an input. Asking me for an input. We'll see that the type now is now integer. Cool. So yeah, you can also call it class, I guess. So the whole point here is that now we can now do something like this, right? So we can now go ahead and multiply them, and then we'll be able to get our answer, right? Oh, 2, 3, 6. So it multiplies. So now it asks us the value here, asks us the value here, and then it converts them to integer, multiplies them, and then it prints the answer. So we gave it this number, and it prints the answer, right? So that's how we do type conversion. Sometimes you want to convert to floats. Sometimes you want to convert to string. So these are all other, depending on what you're trying to achieve. Type conversion, it's something you're going to do a lot, in your code. So yeah, just have that at the back of your mind. And when you are dealing with when you're dealing with strings, yeah, it's kind of like a must for you to do type conversion. Python is very, very smart. He knows how to convert strings to numbers if the content of the string is numbers. But if the content of the string is not numbers, Python will normally throw up an error. So maybe in this case now, we're asking the user to put in the number. And then instead of typing 2, maybe I type home. And then I type 3. Python will throw up an error because here we are trying to, Python will receive whatever we typed in. But at this point where we're trying to convert it to integer, Python does not know how to convert com to integer. If this was 1, 2, 3, Python will convert it, but because it's string, we cannot convert com to integer, so Python will throw up an error. So that's a limitation there. When you're doing your conversion, make sure you are converting the right things. So if it's a number, you can convert it to an integer. If it's a number, you can convert it to floats. But if it's, if it's a string, if it's words, there is nothing else Python can do. So it's going to throw up an error. Very important. I think we have covered quite a number of things, and now we have also covered how we receive input from users. So, but I'm going to enhance that a little bit so that we'll just focus on user input. That does not have to do with numbers, right? So there are different real life scenarios where, as a software engineer, you will actually need to ask a user for inputs, right? For instance, maybe you want the user to maybe you're building a website and you need to receive, you want the user to type in their first name and their last name, right? You will do something like this. Maybe you just want to receive it and print it. This is a very simple use case, but Normally, when you're building a website, of course, you just don't want to receive their name and print it. Maybe you want to save it to the database. So you write more complex code to achieve that, right? So, but in our case, we have been very simplistic. So this is an example code that asks the user to put in their name and then print the name, telling the user welcome, right? That's what this code does. The way Python reads it is, it gets the input, it saves it in a storage location, and then the second line, it prints it, and it adds this additional stuff, welcome, with this guy. So when we run this code, it's gonna ask you, who are you? So you will notice that we can do things like this. If I remove this, let me go ahead and clear. So if I remove that thing and I run the code, Python will still ask me for input. But most of the time, you want to provide a little bit more information to tell the user that you actually want them to type in something. So that's why we'll do something like this. So this is allowed in Python. You can type in these words inside the input so that user can actually type, and you can even go ahead and maybe say something like this. What's your name? And then the user will type. So if I go ahead and I run this guy, it tells me what's your name, and then I can type my name, Augustine. And then Python tells me welcome, Augustine. Right. So this is a very simple code, but there are so many scenarios where you will do something like that. There's so many scenarios where you do something like this, Maybe you want to greet people on your website when they come in, you normally get their name from when they registered on your website, and any day they log in, you always go back to your database, bring their name back, and maybe tell them welcome. Many websites will print something like welcome back or something like that, telling with your name and everything. So that's kind of like how they do it, right? So if you're trying to get inputs from user, you can do something like this, and then you'll be able to print it. So Python runs this code, it gets the prompts, and then it then waits. It runs this code, it prints the prompts, asking you what your name is, and then you put in your name, and then it goes back, and then it prints the name to you, right? So even if you give Python a number in this scenario, it will probably just print it as a string. All right. I think we can wrap up. So wrapping up, we have also covered conversions. We have also covered types. I think these are the very basic things that we need to know. The very last one is that I wanted to tell you about is documentation. I've kind of been doing it a little bit, but now I'm actually going to go ahead and tell you why it's important. So documentation, right? Documentation is very important. We have already kind of seen how it works. We already talked about variable names. In the other lecture, we talked about variable names, how you should name your variables, something that you can remember, right? So you can name your variables properly, and those names helps you to remember what you were doing. So if you come back to your code, it kind of still makes sense to you, right? So we've kind of talked about something called mnemonic variables. Mnemonic variables, very important. It um, helps you remember what you were trying to do the other day when you were writing your code, so that next time when you open the code, you still kind of understand it. And a mnemonic variable is, for instance, name. You input your name. If I go ahead and call this X, for instance, I'm not using a good variable. I mean, this is still a valid code. It works. If you run it, it asks you your name, Augustine. It works fine, right? So it's good. Python doesn't complain. But when I say name, now it makes sense to me, not just to Python. It makes sense to me. So if I come back tomorrow, I will remember, okay, what I was asking them here is name. So that's very important. So it's building on that we have something called documentation. Documentation is very important. As a software engineer, you kind of have to do it, especially from the beginning when you start learning, because you need to develop it as a habit to document your code, your processes. And documentations have way big. They are a whole topic on their own. When you start writing, softwares and doing great stuff, and maybe you get a job and you get into a big team, they expect you to write documentations every time you write code. The simplest way to do it is to add comments in your code. That's the kind of the building block. So when you're writing code, the most important person you're helping is not just it's not just the company, not just your boss, even you, who is going to review the code, who is going to fix it tomorrow when there is a problem, who is going to jump in and make changes when they need to. You need to still be able to remember what does this code do. That's the reason why we have documentation, right? So there are different ways that we document. We have a whole application that actually handle documentations, that you type in a lot of text about what your code does and all of that stuff, like wikis. Then we have readme files that basically is a text file that you can type in what your code does, so that someone who opens your code will see what it does. And those files are usually named .readme. So normally I would have maybe um actually give me a sec. Okay. Those files are usually called readme.md files, right? So this is a readme file. I can type things here. Usually we use this file basically, as the name suggests, as a readme. So let's say this is an actual application, and I'm done writing this application. I have all this code here, all of this, and they do stuff. So in this readme file, this is where I will put in all the information that everyone needs to be able to understand what is happening in my code, right? So I'll probably write things here like, okay, test.py basic. Let's see what is inside it. So this is our test.py file, and from here we can see this guy collects your name and prints it on the console, right? So I'll probably type something like this: basic Python code collects name from user and Print it to the console. This is a classic example of documentation. So what I have just done is I've given an anonymous person who will read this code later a hint of what I'm doing in test.py. There is no rule on how to do this. It's just you being able to pass information. So there are probably several ways that you can format it. You can make it pretty and all of that stuff. So, but just know that the information you're passing in is the most important thing. Another thing is comments, right? So another thing I can do is inside this file itself, I will do something like this. Collect user name. Print user name. Now, this is called comments. This is called comments. So this is another way for you to write documentation. Most times you have to combine all these different methods to be able to have a good documentation. You don't have to pick one over another. It's expected that you have comments in your code all the time. It's also expected that you have README files for the whole thing, right? So comments, very, very helpful. This is a way of telling me what I'm doing here, in a layman understanding. So someone can actually just read these comments and they will understand the code, even if they don't know Python, right? So that's kind of like the other way that we handle documentation, and it's very, very important, right? Okay. So yeah, I think we have quite covered it. The main things that we need to cover, to kind of get started. We've covered inputs, we've covered comments, we've covered variables and all of that stuff. So we can, a bit of a recap. I think I have yeah. All right, let's look at the summary here. Okay, so we have we've kind of gone over most of these things. We've gone over types in Python. Those types being the way that Python observe the values that we give it, the way that it makes sense of it. We have also kind of gone over constants. We've talked about integer division, whereby we talked about the little difference between Python 2 and Python 3. We also talked about reserved words. These are words you're not allowed to use. We went over them the other time in our other class. But if you're joining for the first time, these are the reserved words. These ones are all the words that you're not allowed to use because they are reserved for Python. So you can name your variables anything else, but you're not allowed to use these words. If you use them, you normally run into an error. So you're probably you probably don't need to memorize them, but when you run into an error, that maybe okay, you might have used the reserved word, and then you can go back and check, right? So we have talked about variable mnemonics, making sure that your variables are named correctly so that you can actually remember them, remember what they mean. Talk about operators. We talked about the order of the operators, how Python goes, does brackets first of all, and then it does the exponential, and then it does multiplication and division and so on. We also talked about converting between types, where you can convert strings to integers, and convert integers to floats and things like that. We have also talked about, how you can receive inputs from user. And then we've talked about comments, which is a classic way to, write documentation, right? Okay. I have a little bit of exercise. This is more like an assignment. So also a way for you to practice some of these things. So you're going to write a Python program that will ask the user to put in the number of hours. So this is a classic example of build a Python program that helps workers calculate their pay, right? So if you're writing a program for people who are working per hour, and you want to help them calculate their pay without needing to crack their brain. And this is actually a real life scenario that you can actually find yourself doing at work. So, but you're not going to build a full-fledged software. You're just going to write a very simple Python script that does this. Right. So your script just needs to ask the user for the number of hours they have worked, and then it's going to ask them the rate. Then if the user works 35 hours and the rate is $2.75 per hour, what is their pay? Their pay is 96.25. So it's for you to put this into a program, right? Just a hint, pay will be hours times rates, right? So that will be the pay. So that's what this number is. So you just need to collect these inputs from user and then calculate and then multiply them and then print it to the console. Alrighty, good luck with that and have fun. All right, guys, that's basically all of it today. If you have any questions, now we can have them. It's really been a while, almost 1 hour, 30 minutes. Okay. Do you guys have any question? No questions. Okay. All right, guys. Nice. I mean, it's a recorded session. I understand that most people, wanna go over the recordings anyway. So you get the recordings in the chats. All right, guys. Thanks for showing up today once again. Our turn up is usually low on Friday. I don't know why, but let's say hopefully we'll get more people on Monday. All right, thanks and have a nice day. Yeah, welcome, John. All right, guys. Bye.